All right. So first of all, let me see who is there. Who are the participants online with us? Until now, we have until now. So until now, we have Afiq Hilmi, we have Afika Yunus, we have Aisha, we have Amir Afwan, Andy Yufang, we have Ang Jia Ching, we have Anis Azizan, Chan Kang Jun, we have Elise Ling, Eva Clays, Farah Ilya, Hanim, Fatina, Fatiha, Kavinish, Koh Hui Min, Fong Zi Ying, Lai Jia Huan, Lin Ji Min, Masal Bila. Is that right? Okay. Muhammad Ibrahim, Muhammad Taufiq, Muhammad Muhammad Najmi, Muhammad Adib, Muhammad Abdin, Nabil Ramadan, Nabila Nazri, Nadia, Nadra, Najib Afifi, Nazura, Nuruddin, Olivia, Sui Li Hao, Shafika, Siti Shakira, Shafiq Ikmal, Shukrina, Wan Shafika, Win, Wong Shui, and Yong Ilung. Okay, those are the names. I hope I pronounced them correctly. And I hope I didn't miss anybody. If I miss someone, please forgive me. Just reading the names as it appears on the screen. Okay. Okay, welcome everyone. So let's start chapter 2. All right. So for chapter 2, we're talking about environmental microbiology. So why we need to study about environmental microbiology? Aina Akila is joining. Okay, welcome Aina. Environmental microbiology is something that is of microorganisms. Microorganisms like bacteria, like algae, like maybe viruses and fungi. Okay, so those microorganisms or those living things, those are the main players in water treatment process. Okay, so if we are talking about wastewater treatment, so we have to know something about environmental microbiology. All right. First of all, this is the what do you call the water loop, the nutrient loop, just to see how wastewater is generated. We use the water. Okay, all of us know the water loop, nutrient loop. I think all of you have been introduced before, but this is just a brief revision. How the water originates and how we use the water, here, as you can see here, and how is it treated. Okay, so the water is originated from the rivers, from the waterfalls. We take the water from the rivers, need some purification, then distribution to the different areas like the domestic areas, industrial areas, or agriculture. Okay, and then all this wastewater, as we know, will be converted to waste water. Okay, so the water used in industrial houses for the commercial use, all will be converted to wastewater. Then after that it will be treated. And this is our process here, the treatment process. Okay, this is the main issue that we are dealing with in this course. Okay, the treatment course. Okay, and also something about the collection. Then the wastewater will, after treatment, it will go to maybe reuse or recharge, or maybe just to dispose to the river. Okay, and about the nutrient loop, nutrient, it means the elements that we benefit from and that all the ecosystem benefit from. For example, nitrogen. Okay, nitrogen is available in our food, is available in our nutrition system. Okay, it's one of the elements. Phosphorus also the same. It's in our nutrition system. So when we take nitrogen, when we take phosphorus with our food, then we produce wastewater. Okay, this wastewater also contains what? Also contains the nutrients, the nitrogen, the phosphate, the other nutrients like maybe calcium, maybe potassium. Okay, and then these nutrients will go through the treatment process. Okay, and it should not be wasted. That's why the nutrient loop, as you can see, the brown color, the nutrient loop is closed. It's not open to the river. Why? Because this is the ideal case. The ideal case is that the nutrients will recirculate between the users, the waste, and the treatment process. Then it will be recharged to users. It will be recharged as plants. It will be recharged as fertilizers. It will be recharged as biodiesel. Okay, so this is the reuse. This is the process of reuse of waste materials or of wastewater. Okay. But this is the ideal case, of course, because nowadays we can hear about the pollution of rivers, the air pollution. So why is that? Because this loop is not closed. Okay, this loop is not closed. The brown loop is not closed. Many of the nutrients uh, uh, go out of the loop and then polluted the river and okay. So this is only just to have a brief idea about water loop and nutrient loop. Okay, so we are dealing with the treatment and some of the collection process. All right. So now, who are the important who or what is the important players in environmental microbiology? Those microorganisms that you can see here, bacteria, viruses, fungi, protozoa, okay, algae, those are the main players. Those are the main players in the treatment process. Okay, and of course they live in one community. In one community. Mostly we will be dealing with the bacteria. Okay, in most of the treatment processes that we will talk about, we will deal with bacteria. So when we represent to microorganisms, that means it is the bacteria. Okay, all right. So let's continue. Now, the importance of these organisms in sewage treatment plants is to biodegrade the organic and the inorganic matter. So, if we ask a question, what is the role of bacteria? Why we need bacteria in wastewater? Because this bacteria, it is the one who is going to biodegrade, who is going to break down the organic and the inorganic matters. Okay, organic matter and inorganic matter. Those are complicated compounds. Complicated compounds. So the treatment approach is only to biodegrade the organic and inorganic matter into simpler compounds. So this is the main point. This is the strategy. Okay, so the organic matter in the presence of oxygen, okay, it will be converted to CO2 plus H2O and other new cells. Okay, the new cells means that bacteria, which is the dead bacteria, and also other compounds that is produced from the organic or inorganic matter. Okay, is that clear? Okay, all right. Um, so let's continue. Now, here we will just have a brief background about what is the pyramid. Okay, what is the pyramid between different levels? Okay, between different trophic or food level according to their size, according to their behavior, according to their features. Okay, first of all, humans and animals, big animals, okay, are above the the pyramid. Okay, and they are above the pyramid. Okay, somewhere here above the pyramid. Okay, because we humans and also the animals, okay, the animals, humans and animals. Okay, we feed on everything. Okay, we use everything. We use the aquatic life. We take fish. We take um, all the living in the sea. Okay, we feed on animals. We feed on plants. So we are the top level. Okay, then comes the smaller organisms or smaller animals. Okay, here the higher living organisms. Okay. Then comes the rotifers. Rotifers, those are multicellular aquatic, multicellular aquatic creatures or living things. The size is from 0.1 to 0.5 millimeters. Okay. Then the smaller is the protozoa. Protozoa, those are single cell and free living, or they are parasitic, and the size is from 0.01 to 2 millimeters. Okay, they are very small. You cannot even see it by your naked eye. And then comes the bacteria. So the bacteria is here. Okay, after bacteria comes the organic matter in the food. So there is nothing smaller than the bacteria. Bacteria and viruses. It is a single cellular living creature. Okay. So what is the basic idea here is that every group or every living thing in one level, they feed on the level which is below. They feed on the level which is below. So, for example, rotifers feed on protozoa. Protozoa feed on bacteria, and then finally, bacteria feed on the organic matter, or what we call it, the food, but this food is for bacteria. Okay, so this is the organic matter. So this is just a basic idea about the levels of or the trophics between microorganisms or between organisms. Okay, so these are some shapes for the rotifers. You can see the rotifer is a bit larger than protozoa, and the protozoa has so many shapes, but it's smaller. This is only just to have an example. Okay. So now let's have a brief background or brief some information about bacteria. Okay, so bacteria, those are why we focus on bacteria. Once again, why we focus on bacteria? Because it is the main player. It is the main player in wastewater treatment. It is the one who's going to feed on organic matter and feed on the waste matter. Okay, so those are small organisms with size between 0.5 to 5 micrometer. Okay, they are very, very small. They present maybe individually, but mostly they present in pairs or chains. Okay, in pairs or chains. with different kind of shape. You have the rod shape, the spiral shape, spherical, helical shape. Okay. Of course, they are important in wastewater treatment, as we said just now. They are single microorganisms, and you can imagine that they can reproduce through the binary fission, and will double themselves within 15 to 13 minutes. From 15 to 30 minutes, each one bacteria will double itself into two bacteria. Those two bacteria, after 15 minutes, they will become 4. The 4 will become 8, and the 8 will become 16, and so on. This is the binary fission, as you know. Okay, these are some shapes of bacteria. As you can see, we have the rod shape, have the spherical shape, some helical shape. Those are the chains. You can see here. This is the chains of bacteria here. Okay. Yeah, so many shapes, so many features, so many kinds, thousands and millions of kinds of types of bacteria. Okay, I can call it uncountable kinds of bacteria. Right? So these are some typical shapes of also for bacteria. Okay, I will post some videos for you on the e-learning about bacteria. Okay, this is a video. Now I will play this video. You see how the binary fission of bacteria in each or in every in a small time.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
All right, so this is just a short video to show the reproduction of bacteria. If we have one bacteria, after one day, it will become 5 billion bacteria. Okay, you can imagine how this feature is really interesting. Okay, so okay, so let's continue. Okay, now we have different classification of bacteria, and this classification is very significant to define the wastewater treatment method required for the wastewater treatment for the wastewater it is required for defining the method or the technique required for treatment of wastewater. It depends on the type of pollution in the wastewater that the bacteria will target. Okay. All right. So we can classify bacteria according to energy and carbon source, and also we can classify it according to the way it utilizes the dissolved oxygen. So let's start. Let's have a look here. We have the classification of bacteria according to energy and its carbon source. So we have two types here. We have two types. We have the type number one. It is called the heterotroph. Heterotroph. Those bacteria that use the organic compound as carbon and energy source. Okay. So the heterotroph will feed on the organic. On the other hand, we have the autotroph. We have the autotroph. So the autotroph will feed on the inorganic compound. Inorganic compound. Because as if I want to give example, as humans, when we feed or when we take food, we take drinks, so we take this food in order to get energy, correct? So also bacteria, its food is the carbon. Okay, carbon is the food of bacteria, right? So when it needs energy, it has to attack or it has to find a source of carbon. Okay, So this source of carbon, it can be organic carbon or it can be inorganic carbon, right? So any example of organic carbon? Can you give me some example of organic carbon? You can write in the chat. You can write in the chat an example of the organic carbon. You can just write the formula or the chemical formula if you remember it, or the name of the compound. Oxygen, nitrogen. No, we are talking about organic compound, organic carbon, CH4, right? CH4, correct. CH4 is organic compound, the methane gas, okay? Methane gas is organic. And what about the inorganic? Inorganic carbon. A compound contains inorganic carbon. Just like what? Yes, very easy. Basic chemistry. Carbon dioxide, correct. Carbon dioxide is inorganic, okay? Carbon dioxide, carbon monoxide, calcium carbonate, sodium carbonate, all the carbonates, water. Water is inorganic, correct, but it does not contain carbon. Okay, water is H2O, right? It's H2O. This is water. Okay. Okay, so it's just to refresh our mind. Now we know that we have heterotrophs, those who feed on organic, those who feed on organics. And we have the autotrophs, those who feed on inorganic. All right. We have the classification, the other type of classification, which is according to utilization of dissolved oxygen. Now, we humans, also the animals, and the plants, we take the gas oxygen. Okay, but bacteria, which is living inside the water, which is living inside wastewater, okay, swimming in the wastewater. So where is the oxygen that it will take? It will take the dissolved oxygen. But from type to type, from bacteria to another, it will be different how they take this dissolved oxygen and from where they are going to take it and they are going to use it. Are they going to use it from the wastewater itself, the dissolved oxygen directly dissolved in the wastewater as O2, okay? Or they are going to take it from other compounds which contains oxygen. And that's what we have here. We have the aerobic and we have the anaerobic. Okay, we have the aerob bacteria, those who using dissolved oxygen during the decomposition of organic compound. So they are using dissolved oxygen, which is dissolved as a gas, okay, during the decomposition of organic compound. Those dissolve the organic compound or decompose the organic compound and use the dissolved oxygen from the water. Okay, anaerobic means that in the absence of dissolved oxygen, okay, there is no dissolved gas in the wastewater. Okay, so this type of bacteria will become active, which is the anaerobic. Okay, the anaerobic. Those use oxygen in the form of different compounds. So they use the oxygen from these compounds, the nitrate, sulfate, maybe the phosphate, maybe carbonates, okay? So they use the oxygen from these compounds, not from dissolving in the wastewater as a gas, okay? And we have some kind of smart bacteria, more smart, which is the facultative. Facultative means that they can adapt both conditions, the condition of aerobic and the condition of anaerobic. Whether there is dissolved oxygen or there is no dissolved oxygen, they can still live. Okay, they can use the oxygen dissolved as a gas, and they also can use the oxygen included in radicals like carbonate, like nitrate, like sulfate, etc. Okay, so this is another kind of bacteria, which is, I call it the more smart bacteria. Okay, uh, so if we continue now, this is only a brief background about the second player in our process uh, of wastewater treatment, which is the algae. Okay, which is the now for the algae, they are autotrophic organisms, which means that if we go back, yes, we go with this. So autotroph means that they use what? We use the inorganic compound. We use the inorganic compound as their carbon source. So the algae, they are autotrophs. So they use the inorganic compounds. They feed on inorganic compounds. Some kind of algae, they feed on the organics, but mostly they feed on inorganic. Okay, so algae, they generate energy by photosynthesis. By photosynthesis, okay? So they grab the carbon and they use the photosynthesis to produce their energy, okay? And they have to live in the presence of sunlight, in the presence of sunlight. So in the presence of sunlight, they can metabolize the waste products of bacteria. Now, let me just explain this thing. Because I'm afraid you become first. I'm afraid you become confused. So if you are here, just raise your hand like this. If you are focused, raise your hand in the camera. Just if you can hear me, you can hear me. Okay, just raise your hand like this. Can you hear me? Okay, so you are focusing. Okay, good. Okay, that's good. Okay, good. So now for the I can see the smiles now. Okay, now I'm waking up and refreshing myself. Let me have some some water. All right. So here during the presence, now we know that bacteria and algae live together. So what happens actually? It's like a cycle between bacteria and between algae. So let me write here. I just want to write something. Okay. Here we have the bacteria. Okay. And here we have the algae. Right. So we can make a loop between bacteria and algae. Okay. Between bacteria and algae. Like this. Okay, just putting a simple thing. Okay, now bacteria will decompose the organic matter. Okay, we agree on this. Once the bacteria decompose the organic matter, okay, it will produce CO2 plus H2O plus what? Plus new cells. New cells, those contain NO3, PO4, CO2, of course. Okay, so these products will be produced and they will still included in the wastewater. Okay, now comes the role of algae. So the algae will come and feed on these compounds. Will feed on the CO2, will feed on the NO3, will feed on PO4. All right. After they feed on those. So they will break down the bonds between the nitrogen and the oxygen here, in the phosphate and the oxygen, okay? Between the carbon and the oxygen. So what will happen? The oxygen rate will increase in the water. So they are breaking the bonds, they're breaking the bonds between CO2, between the NO3, between the 3O4, okay? So they will produce more oxygen in the wastewater. So that's much beneficial for the bacteria to live and to take more oxygen and to decompose more organic matter. Okay? After they decompose more organic matter, they will produce the CO2, the NO3, and the 3O4. Then comes the algae. They will feed on them and produce more oxygen. So it's like a loop. It's like a cycle. Okay, so they cooperate between each other, the bacteria and the algae. Okay, so this is the process, right? So once the algae feed or metabolize or decompose those waste products of the bacteria, which is the CO2, the phosphate, the carbonate, okay, they will increase the dissolved oxygen level in the water. That means they are supplying oxygen to the microorganisms, right? Understand? Any question? Okay, it's very simple and very easy. Okay, so we just delete those things. Okay. Okay. So the rapid production in the presence of high concentrations of nitrogen and phosphorus. Okay, because nitrogen and phosphorus are presented as nitrate, as phosphate. So those are the main motivators or the main food or the best source for algae to reproduce and to live. Okay, so in the presence of high concentrations of these, we will find more algae. Okay, but if there are too much of algae in water, that will cause adverse impact. That will cause adverse impact, which means that it will cause taste and smell problems. It will reduce the intensity of light penetration. Why? Why will it reduce the intensity of light penetration when there are so much algae? Can you guess? Can you just write in the chat why there is reduction or reduce for the intensity of light penetration when there are so many algae? What happens actually? If you want to speak, the mic also can. Algae use the sunlight. Okay, but how the sunlight will be reduced when the algae is much produced? We have, okay, they cover the surface of water, right? Yes, you're correct. Najib and Eva, you are correct. So the algae will cover the surface of water body, okay? Cover the surface of the water body. So that will prevent the sunlight from penetrating into the water body. And then what happens eventually? The fish, the submarine will cause to die off. Die. This is one of the adverse impacts of the high production of algae. Okay. So these are some shapes of the algae. Some shapes of the algae, as you can see here, we have different shapes. Okay. So now comes to the important question. Algae are plants or animals? Let me see. Algae, are they plants or animals? You can say in the mic or you can write in the chat. Up to you. So Are they animals or plants? Or they are plants? Okay, plants maybe. Or plants maybe. Plants. Neither. Oh, who said neither? Who said neither? Africa. Yes, you are correct. Africa is correct. So they are neither plants nor animals. They are neither plants nor animals. Okay? Okay. So they are neither plants nor animals. Why? Although they use photosynthesis like plants, but they don't have any roots, they don't have any leaves, they produce with or they reproduce with something like the binary fission. Okay, so it's totally different, and they are not animals because the living. I mean the how can I say the living way, okay, the way they live is totally different from animals. So they have some features from animals, they have some features from plants, but they are neither animals nor plants. Okay, they are algae. They are algae. That's all. Okay, algae is algae. Okay, so they are neither plants nor animals. They are not fungi. Okay, so they are something different. Just like when we say fungi, they plants. No, we cannot say that fungi are plants. Okay, although we make plantation or cultivation of fungi, but it's not a plant. Okay, so they are because also they are single cell. Okay, some species are multicellular, some species are single cell. So they are different from plants, different from animals. You can see here how is the algae is making, we call it the blooms. Okay, we call it algal blooms. Okay, these algal blooms is on the surface of wastewater, and these blooms which uh, prevent the sunlight from being penetrating, and eventually what happens, fish die. Eventually what happens, fish will die. die. Okay, so this is one of the adverse impacts uh, of the covering of water with so many. Okay, now let's go back to bacterial growth. Bacterial growth, as we said about the bacteria, it is the reproduction of bacteria is following the asexual type. Okay, cell division. It's called the cell division. Okay, or binary fission. And as we saw in the video, so one bacteria divided into two every 20 minutes, it will produce more than 5,000 billion bacteria in one day. How strange, yeah, how interesting. Okay, this is another video, but it cannot play, but it's okay. It will show just bacteria how it reproduce in the lab. I will post it on the e-learning, so don't worry, you will see it on e-learning. Okay, so this is also some shapes of bacteria under the microscope. All right. And what by bacterial growth? Okay, when we talk about bacterial growth, we are not talking about concentrations. Okay, for example, when we put salt in the water, okay, so we talk about concentration. We have 10 milligram per liters, 100 milligram per liters, 1 gram per liter, okay, like that. But in bacteria, we cannot say like we have 1 milligram per liter of bacteria. Mostly not like that. Mostly when we talk about bacterial growth, we are really referring to the number of cells, okay, to the number of cells, not the size, not the weight, okay, we are talking about number. So we have 1,000, 1 billion, 1 million, 5 billion, like this, okay? So how do we calculate this number? it had different approaches, but maybe sometimes they counted one by one in a certain area. So they focus in the microscope, okay, on a specific area, like a small area, and they count the bacteria there, how much they are, okay, and they multiply this area by the whole area of the lab, something like that, okay. So they can estimate how much bacteria is there in the circle in the lab. Okay, I will post more videos about bacteria in the e-learning, so don't worry. Okay, and of course the bacteria, when it grows, it will accumulate into colonies, hundreds, thousands of cells. Okay, so one colony should have millions of bacteria that, of course, cannot be seen individually by the naked eye. All right, very nice. This is the last thing in this chapter. After that, you will have a break soon. So just be patient. But this is one of the important things that we have to focus on when we talk about bacteria. Okay, when we talk about bacteria. Now, what is this? This is called the bacterial growth curve. Bacterial growth curve. Now, any kind of bacteria, whatever it is and wherever it will live, whether it lives in our body or whether it lives in the wastewater or whether it lives in the air, so it will follow a similar curve. It will follow similar curve to this. Okay, so a curve like this represents the time on the x-axis and the number of bacteria on the y-axis. Okay, so we have the time here and we have the number of bacteria on the y-axis. So what happens actually at time 0 and at the first of the period when the bacteria is trying to adapt a new environment. Okay, so for example, when a bacteria enters the wastewater, let us make it theoretically. When one bacterium enters the wastewater, what will happen? First, it will go into an adaptation phase. Adaptation phase, which is called the lag phase. Lag phase means that it's a new environment for the bacteria and it wants to adapt the new environment. Adapt new environment means that it has to adapt the acidity of the environment maybe or the alkalinity of the environment. It wants to adapt the pH, will adapt the temperature. Okay, so different conditions for the bacteria it has to adapt. Okay, so and this is called the lag phase. This is called the lag phase. So this is the first phase. Here there is no reproduction of bacteria. There is no activity of bacteria. Just adaptation. Okay, just adaptation. Okay. After that, bacteria has adapted the environment. It will start to do what? It will start to increase. It will start to reproduce. Okay, following the exponential growth phase or the log phase. Okay. In this phase, the reproduction of bacteria is very rapid, is very high, okay? Rapidly increasing. And as you can see, the curve is sharp. The curve is going sharp, okay? Which means that it is rapidly increasing. And the death rate is very low. So the production rate is very high, the death rate is very low, okay? Until it reaches a phase which is called the stationary phase. Why it reached the stationary phase? Because maybe the food is coming less or is not enough is not so enough for all bacteria. Okay, there's no sufficient food, no sufficient organic matter, and so on. Okay, and also in this phase, the reproduction rate will become lower and the death rate will become a little bit higher. So there will be a balance between reproduction and death rate. Okay, there will be a balance between reproduction and death rate. Okay, after that, what will happen? There is no sufficient food, there is no supply for more food, the oxygen is getting less, so the death rate will become higher. Death rate will become higher, and reproduction rate will become lower. Bacteria start to trying to survive. Okay, so that causes the declining of bacteria, the decline of bacteria until it reach the zero, until all bacteria just decline or death. Okay, because of the lack of food and lack of oxygen. Okay, any question about this? About this bacterial growth rate? So I believe it is maybe something easy and simple. So if we just continue, so this is the explanation of each phase. What happens in the lag phase? Okay, what happens in the exponential or the log phase, and the stationary phase, and the depth or endogenous phase. And each phase has its own features, as we explained just now. Lag phase is the acclimatize or the adaptation phase. Okay, the exponential or growth, there is rapid growth, reproduction. Okay, reproduction, because there is an excess substrate. Okay, what is the substrate? Substrate is the food. From now on, we will call the food of bacteria as substrate. Okay, as the substrate. All right. So, and then comes the stationary phase. Here, the population will remain stationary. Okay, why? Because cells have exhausted the substrate. Okay, or maybe the growth of new cells is offset by the death of all cells. Okay, and then comes the final phase, which is the decline of the endogenous phase. And this phase, the death of bacteria will become more. Okay, so this is in the lab how the vials, those in the lab that we use to put the organic matter and to mix it with the bacteria, okay, how it looks like in the lab. In the lag phase, in the exponential growth phase, then comes to the stationary phase, then comes to the death phase. Okay, and you can see the colors are different. Here, the death cells is in the gray. So in the stationary phase, it will become more. In the death phase, it will increase until all the bacteria is dead. Okay, so that's for lecture 2. If anybody have any question, just please let me know before we do something else. Okay. Okay, no question. No question. Okay. So until now, we now we have finished chapter 2, and we will go to chapter 3, but after a break. Okay, so we'll give you a 10 to 15 minutes break. Go and have some tea or some snacks, refresh yourself, and we'll see you after 15 minutes. Okay? See you after 15 minutes. No. Okay, we are back now. We are back. So I hope everyone is here. Okay, hello everyone. Can you hear me? Just write number 1 and raise your hand. Show yourself on the camera if possible. Okay. Okay. Eva, Muhammad Najmi, Chan, Lai, Elise, Ling, we have Kong, Ziging, and also Nabil Ramadan. Okay, Yong. Okay, Yong Long. Okay, okay. Mazal Pila. Okay, can hear. Okay, that's good. All right, everyone. So now let's start in chapter 3. Yeah, chapter 3. We will go forward now to chapter 3. Chapter 3, we will start now in the, let me say, the core of the course. Chapter 1 and chapter 2 was only, it's only background, only briefing, introductions. It's only just playing a game, okay? Now we will start working on chapter 3, so I need you to concentrate, to focus. Okay, so let me share the screen. Okay, now we share the screen. As you can see, this was chapter 2, and now we go to chapter 3. Okay, good. Everyone is here. Okay. All right. Use my feet. Now I'm ready. Okay, guys, my friends. Okay, so first of all, chapter 3 is talking about wastewater, types, characteristics of wastewater. Okay, types and characteristics of wastewater. First of all, types of wastewater according to the origin of wastewater. Where does it come from? Okay, it comes from domestic areas like houses, like universities, schools, okay, or it can come from industrial activities like pharmaceutical industries, the POMI, the textile. Where's the POMI? POMI is the palm oil mill effluent. Palm oil mill effluent. Okay, and in Southeast Asia, in Malaysia, Indonesia, there is very famous in planting the palm oil. Okay, and producing palm oil. Okay, so the wastewater of the palm oil is something really difficult to treat. So that's why it's one of the most difficult wastewater types to be treated globally, actually, in the worldwide. Okay. So for domestic wastewater, it is normally generated from toilets, from skins, from bathrooms, okay, from the shower. And this is the source of industrial of domestic wastewater. Sorry, of domestic wastewater. And industrial wastewater, it is normally generated by industries. So the quantity, the quality is different from domestic wastewater, industrial wastewater. Okay, so which one do you think is the quantity is higher? Is it the domestic wastewater or the industrial wastewater? Which one is higher, do you think? Try in the chat. Which one do you think is higher in terms of quantity? Quantity. Industrial. Industrial is higher. Industrial. Industrial is higher. Why? Why is not the domestic? Why industrial? Okay, we have to differentiate between two things, the quantity and the quality. Okay, the level of pollution, let me say. So the level of pollution in the industrial is much higher, but the quantity is lower. Okay, because factories, industries, the quantity of water it is compared to the people living, to the millions of people living and producing wastewater every day. So the domestic wastewater is, the quantity is higher. Okay, for the factories, the number of factories opposite to the number of people is low. So the quantity is low. Industrial wastewater, the quantity is lower than domestic wastewater. Okay. Okay. Okay, fine, no problem. So the characteristics of wastewater, we have three types or three categories. Okay, we have the physical, we have the chemical, and we have the biological characteristic of waste. Okay, uh, physical characteristic. Okay, when we talk about something physical, so the physical characteristic means the color, means the odor, means the temperature. Okay, so this is the physical characteristics. So the color depends mainly on the wastewater constituent. What does it contain? If it contains more organics, if it contains more metals, it contains more like the dyes. Okay, those dyes used to coloring the clothes and coloring the industry. Okay, this will cause the color to be different. The other depends on the activity inside the wastewater. Okay, you have to take notes about this. The other depends on the activity of bacteria and organisms in the wastewater. Okay, if the activity is aerobic activity, which is if the wastewater is open to the air and there is mix between, I mean, there is an air supply to the wastewater, which makes the condition aerobic. Okay, so this is not something significant. The other is not something significant. But if the condition of wastewater is anaerobic, so yes, it is something significant because because there will be a release of hydrogen sulfide, which smells like the rotten egg. Okay, and this gas or this kind of gas, the smell is very bad. Okay, and it causes another problem. All right. So the other problem depends on the condition of wastewater, whether it is aerobic or anaerobic. Right. Now, thirdly, the temperature. Temperature. Of course, it is higher than the water, but if the temperature is very high, like above 38 or above 40, of course, the bacteria cannot live so long. Okay. So the effect of temperature is on the microbial growth rate. Microbial growth rate. The more wastewater is warm, let me say, not hot, warm, okay, the more active the bacteria will be. Okay, in cold temperatures, the bacteria normally is not so active. It's not so active, okay, and activity is less. And we will see later on in the equations how this is reflected in the equations. Okay. And the fourth characteristic, which is the most important, is the solids, or the we call the suspended and dissolved solids. Okay. Now these solids caused by the some kinds of waste, caused by the sand, caused by clay, by plant fibers. The presence of these kind of waste will produce solids or produce solids. Some solids are very fine, some solids have bigger size, okay, different sizes. Just like the sand, when you have a quantity of sand, it has different sizes and different shapes, okay? Okay, so for the solids, it is divided into two types. We have the suspended solids and we have the dissolved solids. Okay, for the suspended solids, it is the solid that can be captured on the filter. When we filter the wastewater, it will be captured, it will be caught, okay, on the filter paper. While the dissolved solids, those cannot be filtered, okay, those cannot be captured easily in the filter, okay, right? So this is the difference between dissolved and suspended. And the total or the combination between dissolved and dissolved and suspended, those are the total solids. Total solids. Okay, mainly or majorly we use the milligram per liter uh, to represent the concentration. Okay, that's what we're talking now. Suspended solids, those solids that are non-filterable, non-filterable with specified filters. Okay, they are not volatilized at 103 degrees. Okay, so if you heat these suspended solids at 100 degree, it will not change. Okay, it will not change. It will keep as it is. Those are the suspended solids. Okay, now for suspended solids or for the total solids, we have two subcategories. Okay, suspended and dissolved. It depends on the size of the solid. Okay, whether it is can be seen, can be captured, can be filtered or not. Okay, now according to the or following the heating, okay, if we heat until the ignition heat is 550, some solids will change and will volatilize, and some solids will be non-volatilized. Okay, that's what we call the volatilized suspended solids. Okay, it is a portion of the suspended that can be volatilized at 550 degrees. Okay, at 550 degrees, and this this is the volatile suspended solids. Okay, for the dissolved solids, those solids that are in solution, they are therefore filterable. If you have sodium chloride, okay, the table salt, okay, the normal salt we put on the food, okay, this salt, if you dissolve in the water, if you dissolve it in the water, okay, it will be dissolved solids. It will be considered as dissolved solids. Okay, if you filter the water, you will not capture the dissolved solid. So this is called the dissolved solid. Now also the dissolved solid has two portions, as volatile and non-volatile. Okay, as volatile and non-volatile. Okay, so in general, the total solids also have volatile and non-volatile. What do you mean by volatile? Volatile means that it will change if we heat it at 550 degrees. 550 degrees, okay? At 550 degrees here, okay? So heating at 550 degrees means that, or if it changed at 550 means that a portion of it is volatile. Those solids volatile, it will change. Okay, just like the organics, the organic solid, like what can I say? The organic solid, and maybe there's some kind of fats. okay, the fats, the grease, the oil, okay, those are organics. So when it is heated at 550 degrees, okay, it will change to CO2 plus H2O. Okay, we change to CO2 plus H2O. And that's we'll see it later. Okay, so so let me continue. Now, in this figure, we see that we have the procedure or how we determine the total solids and total volatile solids. Now, simply if you have a dish, okay, or a pot or whatever, and inside the dish or the pot you have water or polluted water, let me say wastewater, okay, and you dry it on the gas stove or in the oven at 100 degrees, 103 degrees, like here, okay. So this drying will cause the water to what? To evaporate. Will cause the water to evaporate, okay, and will change into vapor, okay. So the water will change into vapor. Okay, and will remain in the dish what? The dry solids. Dry solids. Okay, so this dry solid is the total solids. Is the total solids. Okay, why? Now go back to the example of table salt, sodium chloride. If you have sodium chloride in the water and you dry this water on the gas stove until all the water evaporate, what will happen? You will notice that the solid is still remaining in the glass or in the kettle, let me say. Okay, you will see that the solid is still, or the salt, the white scaling, okay, still remaining in the kettle. So this is the dry solid. It was dissolved, but now it is dry. Okay, and also the suspended solids. Any suspended solids here, okay, it will also be included in the dry solid. So this is the total solid. It was dissolved and suspended. All is here. Now we want to see the portion. We want to see the portion of solids which is volatile and non-volatile. So what we do, we make igniting. Okay, igniting is not only drying; it's a burning. It's a kind of burning. Okay, combustion. Okay, so combustion or ignition at 550 degrees. Okay, to destroy all the organic compounds. Any organic compounds will be destroyed, will be changed, will be volatilized, as we say. Okay, will change to CO2 plus H2O, to carbon dioxide and water. Okay, it will change and will remain in the dish what? The inorganic matter. Okay, so this is the what we call the ignition, the volatile and non-volatile. So the non-volatile is called fixed. Okay, the fixed. So if you want to know the concentration of total solids, okay, so the concentration of total solids is the weight of solids here divided by the volume of water, divided by the volume of water, the original volume of water. Okay, so and the total volatile solids, we have the fixed solids and we have the dry solids, so we can know the volatile. Okay, we have the fixed at the end, and we have the dry solids, so we can know the volatile. Okay, so this is simply how to determine the suspended, the total solids concentration. All right, any question? Any question until now? Everything is okay? Okay? All right, good. So we have to want to move now to to the other slide. Continue. Okay, so the measurement of total solids is to evaporate a known volume of sample to dryness and then just weigh the residue. Very easy, very simple. Right? Now, the measurement of suspended solids. Let us go to the measurement of suspended solids. Now, in suspended solids, because those solids are suspended, so what happened actually is that we have to filter the water, not to dry the water. Okay? Because if you dry the water, you will have a mix between suspended and dissolved. So you will not be able to differentiate which one was suspended and which one was dissolved. So from the beginning, what we do, we just make a filtration. Okay, so for the suspended solids, we make filtration. For the dissolved solids, we make what? We for the total solid, for the total solid, we make drying. So let me just write it here. Okay, so to measure suspended solids, okay, that means filtration. Okay, but to measure total solids, that means drying. Okay, so filtration or drying. Okay, because in any question or any problem, you say like, okay, we have a certain volume and we make drying for this volume. Okay, so we make filtration for 100 ml and we make drying for 50 ml, and then we got this and we got that. So you have to know which volume has been dried. So this is for total solid measurement. Which volume has been filtrated, okay, filtered, sorry, filtered, so that volume is for the suspended solid measurement. Okay, all right, good, good. And so after we filter the suspended solids, after we filter the wastewater, which contains the solids, okay, we have to dry what? The filter paper itself. As you can see here, this filter paper, we make a drying for the filter paper. Why? Because of the moisture. Okay, after filtration, the filter paper is still wet, still have moisture. Okay, so that means we have just to dry this filter paper to remove the moisture, right? And after drying, we will have the dry suspended solids. So this filter paper contains only the suspended solid. What about the dissolved? The dissolved solids are remaining here. Okay, the dissolved solids remaining here with the water. Okay, cannot be seen. Cannot be seen. Okay, so and after we make drying for the suspended solids, now we have the weight of suspended solid. But we know that a portion of suspended solid can be ignited, can be volatile. Okay, so we make ignition at 550 just to differentiate or just to measure how much the percentage of the volatile suspended and the non-volatile suspended. How much the percentage of the volatile, how much the percentage of the fixed solid. Okay, so we go to the ignition process, we go to the ignition step. Okay, and we convert the portion which is the volatile to CO2 plus H2O, and after ignition, also some solids will remain as it is, which is non-volatile, which is the inorganic. Inorganic like sodium, like calcium, those are inorganics. Okay, while the ethanol, the methanol, those are organics. Okay, so they will change. The fatty acids, the grease. Okay, right. And so this is the equation. We have the suspended solids, which means that the weight of dry solids here, okay, the weight of the dry solids divided by the weight divided by the volume that has been filtered. That has been filtered. So the weight of the solid divided by the volume that has been filtered. Okay, and volatile suspended solids, how can we measure it? Just by measuring or subtraction of the fixed suspended solids from the volume of the dry solids. Okay, the question until now, I think everything is clear. So if everything is clear, we can move forward to the next. Now we go to the dilution. Okay, sometimes before we run the experiments, and especially suspended solid experiments, we have to dilute the sample. Why we dilute the sample? Why we dilute the sample? Can you guess why? Here it says that high concentration of suspended solids, if you have high concentration of suspended solids, it is recommended to dilute the sample. Can you guess why? You can open the mic if you want, or you can write in the chat. No answer yet? Okay, why we dilute the sample? We have a sample that has high concentration of solids, like sand. Okay, it's full of sandy material, full of sandy matter, clay, and we want to filter this sample. Is it okay to filter it directly? Can, but the better is to make a dilution. Dilution means that we bring a small amount of the concentrated sample and we just dilute it. Just like when you make the syrup. We all of us know the syrup, okay? You go to the restaurant and you order syrup. What they do actually, they bring the concentrated syrup, they mix it with some water. So this is dilution. Okay? So why we should make some dilution to the wastewater before filtering, before filtration, or before drying? Guess why? No idea. Okay. This is something practically to make it easy for us to handle the sample. Okay. Imagine that. Sorry. Imagine that we have a muddy or high concentrated polluted water. We want to filter it. So from the first drops, from the first few drops, the filter paper, what will happen to the filter paper? It will block. It will be blocked. Okay, and you will not be able to filter more. Okay, because the solids are so heavy. That's something practical. So we have to make dilution. Also, to avoid any errors that might happen through losing some solids, okay? Losing some solids and the sample is not very well mixed. So it is something more too practical in the lab, okay? But it's okay. If you have high concentration, it is recommended to dilute the sample first. Okay, what kind of water we use to dilute the sample? It has to be distilled water or deionized. Deionized, which means that it is pure H2O. Pure H2O, okay? This is in order just not to change the characteristic of the original wastewater, okay? We just want to change the concentration from concentrated to something diluted. Okay, and that's all. Okay, so this is only the purpose of dilution. Okay, after we run the sample, the experiment using the diluted sample, we will get the result, and then we will multiply that with the dilution factor. We dilute twice, okay, we multiply by 2. We dilute 3 times, 4 times, okay, so the result has to be multiplied by the dilution factor, okay. Okay, a quick example. We have total solids and suspended solids experiment was carried out on a wastewater sample. Okay, and those are the relevant information that we got. First, we have the weight of the filter. Okay, the empty filter still not used, and then we have the weight of the empty dish. Okay, and then we have the weight of the filter and residue on the filter. Okay, because some wastewater was filtered and some wastewater was dried. So after filtration, the filter has residue, has solids on it. So the weight of the filter plus residue is here. And the weight of the dish and residue, okay, because this is the portion of the water that has been dried. Okay, we said that we want to measure the total solids, we have to go for drying. We want to measure the suspended solids, we have to go for filtration. Okay, the volume of sample which was filtered, the volume of sample which was dried. Okay, so in that case, you can know that we have two volumes. We have volume that was filtered and we have volume that was dried. Make it silent. Okay. So here we have to calculate what? We have to calculate the concentrations of total solids, suspended solids, and dissolved solids. Okay, so actually what we will do is that first of all, we have to find the total solids. We have the volume of suspended solids. Sorry, we have the weight. We have some annotation here. We have the weight of the dish plus the dry residue. Okay, and we have the weight of the empty dish. Okay, we have the weight of the dish with the residue in it, and we have the weight of the empty dish. So the difference between them is the weight of the solids that has been dried, which is called the total solids. Is that total solids? Now all of this has to be divided by 50. 50 what is 50? 50 is the volume that has been dried. Okay, and then multiplied by 10 to the power 6, which is just to convert the units from gram per milliliter into milligram per liter. So we multiply by 10 to the power 6. Okay, the final result is 380. All right, and then comes the suspended solid measurement. For suspended solid measurement, we have to consider the wastewater that has been filtered. Not dried. Okay, so for suspended solids, here we have the weight of what? We have the weight of the filter paper with the residue on it. Okay, and we minus the weight of filter paper empty, so we have the weight of the residue only. Okay, that was suspended. Okay, that's why we measuring the suspended solid. All of this has to be divided by 150. 150 is the volume that was filtered. So don't mix up don't mix up between filtration and drying. Okay, because this is something that some students they make mistake when they try to answer such questions. Although the questions are straightforward and easy, but they mix between drying and filtration. So please take care. Okay, multiply by 10 to the power 6 in order to change or to convert the units. Okay, so the final answer is 250. All right. So here we have the total solids, we have the suspended solids. So what else can we calculate? We can calculate the dissolved solid, right? The dissolved solids just minus total solid minus the suspended solid will give us the dissolved solid. Okay. So any question until now? If you have any question, please let me know. Okay, everything is okay? Okay. Okay. Fine. Okay. So let us continue. Sorry. Okay. So let's continue here. Let's continue talking about the chemical characteristics. Okay. So the first we talk is about the physical characteristics. Now we talk about the chemical characteristics. When we talk about chemical characteristics, basically we are talking about organics and inorganics. Okay, organic compound and inorganic compound. Right? So first of all, what is the organic compound? Organic compound is compound that contain carbon in combination with one or more elements. Okay? Of course, there are a few exceptions like carbon monoxide, carbon dioxide, carbonates. Those are considered as inorganic. Right? And those are the properties of organic compounds. They are usually combustible. Only by combustible. What do we mean by combustible? When we say organic compounds are combustible, what does it mean? Yeah, I want to see answers. What does it mean? Combustible. Burn easily. Right, Eva. Correct. Burn easily. Does it mean that at any degree or certain degree? Any degree? I don't think so. Yeah, it is a certain degree. Africa, correct. A certain degree. So what is a certain degree? How much is the degree for burning, for combustion, for ignition? For ignition, it is for ignition. Ignition is same as combustion, is same as let me say the burning. Okay, it is at 550 degrees. I wrote it. Yeah. Okay. Najmi and Eva. Okay, correct. So it's 550 degrees. So this is usually the combustion temperature. Okay. Now the second thing is that they have, or organic compound, they have lower melting and boiling points. Okay, melting point, the boiling point is lower, right? And they are less soluble in water. They are less soluble in water. If you want to mix oil in water, probably or mostly it will not be mixed. It will not be mixed. Okay, and they have also high molecular weight. You can see that most organic compounds are complicated, like this. This one, C and Cl and H and the Br. So this is a complicated organic compound, right? So mostly they have high molecular weights. Okay, And the last thing is the most important one, which we can say that they represent as the source of energy, source of carbon, source of food for most microorganisms. Okay, for most microorganisms, they are considered as the of food, source of food. Okay, and this what we call the autotroph or the heterotroph organisms that feed on the organics. Heterotroph that feeds on the organic compounds. Okay, so this is basically about the definition and properties of organic compounds. Now, the source. What is the source of organic compound? The source can be natural, can be synthetic, can be by fermentation. Okay, the natural source is like the vegetable oils, the animal oils, the fats, the grease, cellulose, starch, okay, sugar. Those are organic. The synthetic is like the manufacture, the polyvinyl chloride, the DDT, and variety of compounds that manufactured in the factories. They can be prepared in the factories, okay? And also some other gases and solutions like methanol or ethanol, if they are synthetically produced, so they are considered as synthetic, okay? And formaldehyde, those things. And the the last one is fermentation, like alcohols, like acetone, glycerol, antibiotics, okay, and some kinds of acids. Those are produced by fermentation. Okay, right. Now, according to this, we have classification of the organic matter. Okay, because we know that some bacteria can degrade the organic matter. Some bacteria can go to the cannot degrade the organic matter. Okay, so organic matter also is divided between something that can be biodegraded and others that cannot be biodegraded. Okay, some portion of the organics can be degraded by bacteria, and other organics cannot be degraded by bacteria. Those are called as a non-biodegradable. Okay, so we have biodegradable, we have non-biodegradable. Okay, so this is the difference between biodegradable organics and non-biodegradable organics. Biodegradable organics, those are considered as food for microorganisms. Okay, they are fast and easily can be oxidized by microorganisms, right? For example, like starch, fat protein, alcohol, human and animal waste. Mostly they are biodegradable, okay? They are biodegradable. While on the other hand, we have the non-biodegradable organics, which are difficult, much longer to biodegrade, okay? And, and they are, moreover, they are toxic to microorganisms. They are poisonous. So in the presence of some non-biodegradable organics, the bacteria cannot live. The microorganism will be killed, like pesticides, like in some industrial waste. Okay, those kind of waste will be toxic, and they are non-biodegradable. It cannot be easily degraded by bacteria, by microorganisms. Right? Okay. So let us have a look about the effects of increasing organic waste. So that gives us an idea why we should remove, why we should treat organic matter from wastewater. Okay, because presence of organic matter will cause will be poisonous and toxic to human life and also to aquatic life if the wastewater is disposed and discharged to the rivers, okay, and also it will be harmful to the whole ecosystem, okay, damaging the whole ecosystem, okay. And some organics also can cause cancer, Later on, the wastewater treatment, we will see that we use something we call it chlorination. Okay, we add chlorine to the wastewater at the end of the treatment. Okay, so if organics are still there, if organics are not removed from wastewater, and we want to make disinfection using the chlorine, so chlorine will combine with organics and will cause the trihalomethane, THM. This is the carcinogenic compounds. Okay, those are carcinogenic compounds. But anyway, this is the main effect uh, of of increasing organic waste. Okay, I will stop until here, or we have time. Okay, I think we have time. We just want to. Okay, we have time. We will proceed. We will proceed. We will just mention about the BOD, and we will then we can close the class, close the session. Okay. So please be patient. Okay. So let me just go back to this one. Okay. Here it says that the effects of increasing organic waste in water bodies. One of the effects is depletion of the dissolved oxygen in the water. Depletion of oxygen, which means that the dissolved oxygen in the wastewater or in the water will get lower, okay, will be utilized, okay, will be used. The dissolved oxygen will be used when organic matter is there, okay. Do you understand? So I just want to write this notation, okay. So more organic matter means that less dissolved oxygen. Can you guess why? I like to ask questions of guess. Just make you think. Why? I like the question of why. Yeah, I like it so much. So, hey, sorry. Okay. Write it again. So we have more organic matter in the water means lower dissolved oxygen. So can you guess why? Let me see. Can you guess why? The more organic matter, the less oxygen. The more organic matter, the less dissolved oxygen. Okay. The use of the oxygen for growth. Yes, correct. For growth. For growth of who? For growth of what? There is a utilizing of oxygen for the growth of bacteria, consume organic matter and use the dissolved for growth. That's right. Najib, that's right. Yeah. Elis, that's right. Use oxygen to produce new cells. That's right. The bacterial growth. Of course, you are all absolutely right. When the organic matter is there, so this will encourage the bacteria to come and to attack and to decompose, okay? To be more active. There is food, so come on, let's eat it. So this is what the bacteria will behave, okay? It's just like when you put a free buffet food or how can I say, free dinner for people. So all the people will go for the dinner, okay? Because it's free. So that's what happened for the bacteria, right? When there is organic matter, so bacteria will be more active, more motivated to decompose. Okay, what the bacteria normally needs what to decompose organic matter? It needs what? It needs dissolved oxygen. It needs the dissolved oxygen. So the bacteria will decompose the organic matter and it also will deplete the dissolved oxygen. It will deplete the dissolved oxygen. So that's the important thing about growing organics in the water. Okay, that's the main point of growing organics in the water. Okay, now scientists was thinking that if we want to measure the concentration of organic matter, we want to measure the concentration of this matter that is biodegradable. So why don't we use this feature? Why don't we use this characteristic in order to measure or to indicate the concentration of organics in the wastewater? How? If you bring a cup or a glass or flask or whatever, okay, and this flask contains wastewater, okay, contains wastewater. Then you leave this wastewater for 3 or 5 days. What will happen? The bacteria will start to decompose, yeah, to to eat or to feed on the organic matter there, right? What will happen to the dissolved oxygen? If you have initially like 10 milligram per liter dissolved oxygen, okay, for example, then after 5 days, the bacteria during the 5 days are is um, is eating or is feeding on the organic matter, okay, right? So what will happen to dissolved oxygen? It will remain at 10 or it will be lower. It will be lower, right? It will get lower from 10 maybe to 5 to 3 or to 2, okay? Why? Because bacteria use it. Bacteria has used it. So this is a good indication of the presence of organic matter. Okay, this is a good indication of the presence of organic matter. Because on the other hand, if there is no organic matter, so there will be no bacterial activity, so there will be no reduction of dissolved oxygen. Okay, this is the basic concept of what we call the BOD. BOD. If you understand this concept, you can easily understand what do we mean by BOD without going to the hassle of definitions and dictionaries. Okay, so that is what is shown in this small figure. We have organic waste, so dissolved oxygen will be consumed, dissolved oxygen will get lower, so the BOD will be higher. What do you mean by BOD? BOD is the biological oxygen demand, which means that how much oxygen is required for the bacteria to decompose a specific amount of biological, of organic content. Okay, so this is the definition of BOD, the biological oxygen demand. It is the quantity of oxygen utilized by bacteria or by microorganisms to biologically degrade organic matter. Okay, under aerobic condition, because this is in the presence of oxygen. Okay, so it is the, or in another definition, it is the amount of dissolved oxygen needed or demanded by aerobic biological microorganisms to break down organic material present in given water sample. Okay, all right. So this is the basic idea or the concept of BOD. So from now on, BOD is one of the parameters that will indicate the presence and the concentration of organic matter, not the concentration of bacteria. Be careful. It's the concentration of organic matter. Okay? Not the concentration of dissolved oxygen. Although dissolved oxygen is used, but it is the concentration of the biodegradable organic matter. Okay? Let me write it here as an annotation. So we have BOD indicates the concentration of biodegradable organic matter. Okay? So BOD indicates the concentration of biodegradable organic matter, right? All right. So this is the main point about the micro the BOD. Okay. So any question for now? Any question for now? Until now, any question? No question? Okay. Okay, fine. So all of you are focusing, you are active, still awake, still strong. Good. Very happy to see that. Okay. So we continue. Okay. So here we say that BOD is the most important parameter in water pollution control. Okay. It is used to measure the organic pollution as a basis for estimating the oxygen needed for biological processes. The same thing that we has just now has we were talking about. Okay. And it is also indicator of process performance. Process performance means that how is the treatment of wastewater? Is it good or not? Okay, and what is the characteristic of wastewater that is coming to the treatment plant? Okay, so we measure the BOD to know or to indicate roughly or estimately how much is organic matter. So from now on, BOD is one of the most important parameters. Okay, so BOD test can be done at 5 days. As I told you, we leave a flask or a container for 5 days, and sometimes we leave it for 3 days, but under certain condition, which is temperature. Okay, so the temperature has to be 20 degrees. To be 20 degrees. If it is left for 3 days, so the temperature has to be 30 degrees. Okay, why 30 degrees with 3 days and 20 degrees with 5 days? This is related to what? This is related maybe to the bacterial activity, correct? And it is relation to the temperature. If we have warmer temperature, so 3 days is enough for bacteria. If we have little bit cool temperature like 20, so 5 days should be enough for bacteria to reach its maximum or its indicating level of measuring or degrading the organic or the biodegradable organic matter. Okay, so this is about the BOD. So this is also the general equation, organic matter, the presence of oxygen. Microorganisms will change it to CO2 plus H2O plus some cells, right? And also, 5 days test is for domestic, okay, and industrial wastewater, and this is a global standard, okay? This is a global standard. For 3 days test, this is especially for the palm oil mill effluents, okay, and the rubber manufacturing wastewater, and this is mostly for Malaysia because this special wastewater is here a lot and in significant quantities, and it is actually one of the national what do you call national interests or no, national issues, national environmental issues that it is always a concern for the government or also for the researchers and for the studies here, how to treat and how to take care about the treatment of foamy, okay, because it's related to industry, related to economy, etc. Okay, so this is all about the BOD. So we can see that BOD, as we said, BOD is would be BOD represents what? Again, BOD represents the amount of oxygen that has been utilized by the bacteria to utilize or to decompose the organic matter. So we can indicate the concentration of organic matter by measuring the dissolved oxygen at the beginning of the experiment, 5 days, and at the last day after 5 days. So before 5 days and after 5 days. At day 0 and at day 5, we measure the dissolved oxygen. So we have dissolved oxygen initially and we have dissolved oxygen finally. For example, if the dissolved oxygen initially was 10 and finally it was 3, so that means that the difference is 7. So the concentration of BOD is 7. That's it. If the dissolved oxygen at the beginning is 50, 50, and at the end it is 10, so 50 minus 10, which is 40. So 40 has been consumed by the bacteria, so BOD is 40, like this. Okay, but we have to consider something, that when we run the BOD, normally we make some dilution to the sample, and that causes the presence of a dilution factor. Okay, so principally BOD equation equals, or BOD equals BO initial minus BO final, or dissolved oxygen initially minus dissolved oxygen finally. That has to be divided by the dilution factor. So if the dilution factor is 1 over 4, 1 over 5, 1 over 10, so it has to be divided by the dilution factor. Okay? So this is the BOD main equation. Okay? And this is how can we measure the dilution factor. Dilution factor is the, for example, if I have in a glass or a flask, if we have like 20 ml, okay? So 20 ml, let me write something here on the board. Okay, we have 20 ml concentrated, okay? And we add to it like 280 ml of distilled wastewater, okay? So the total will be 300 ml. So here, what is the dilution factor? Okay, originally we have 20. Originally we have 20. This has to be divided by the total volume. How much the total volume became 300. Okay, so 20 over 300. It is 2 over 30, so it is 1 over 15. It's 1 over 15. So this is the dilution factor. Okay, so the dilution factor has to be divided here. DO initial minus DO final over P. So this is P. Okay? So this is P, right? Okay. So this is about the BOD, about the initial BO initial and BO final. Okay? So this is the BOD test procedure. We have a water sample containing the degradable organic matter. Okay, we just place it in a BOD bottle. There is some certain bottles. We will show you in the video how it is performed. Actually, we have to perform it in the lab, but due to the conditions now, so we will not be able to go to the lab, but it's okay. We can show it in videos. Okay, so we just place it in a BOD bottle. Okay, and if needed, we make dilution with a known quantity. Okay, so we have to make some dilution if needed, if we feel that, and this is related to the experience of the technician. If they feel that the wastewater is always concentrated, so we make some dilution before running the test. Okay, and the pH has to be adjusted to 7.2 in order to make a suitable environment for the bacteria, not so acidic and not so basic. Okay, so it has to be neutralized like 7 or 7.2. Okay, then we make aeration. So we provide oxygen. We provide oxygen to the sample or to the bottle before running the test. Okay, then we measure the dissolved oxygen before, and then we measure the dissolved oxygen after. Okay, and the difference will be the concentration of BOD. Okay. Okay. For a valid BOD test, the final dissolved oxygen should not be less than 1 milligram per liter. This is a standard. This is a standard empirically from the labs, from the experiments that has been done in the lab. Okay. Now, dilution. Dilution also is needed to decrease organic strength of the sample. And then after we get the concentration of dissolved oxygen, we can have the actual value. Okay, I will stop until now. Okay, we will continue the next class. I hope everything is clear to you. If you have any question, please let me know. Everything is clear. Next class, we will continue in explaining about COD, and we may reach chapter 4. But before we leave, we want to arrange for a replacement. So because now there's no time to arrange, to agree on a replacement. Yeah, I will upload the chapter 3 notes in the e-learning, so don't worry. I will upload the notes, inshallah. And regarding the replacement, is it okay for you to have it like on Saturday? I want to avoid any clashes with other class. So is it okay on Saturday? If it's okay, just raise your hand, raise your thumb. Okay, okay on Saturday. Saturday, like 10 o'clock. Saturday, 10 o'clock, 10 in the morning. Saturday, 10 morning. Okay. No, we not change the class. It's only a replacement for one class because you missed one class last week, sorry. Because you missed one class because we missed one class last week. So we want to make replace that one. Okay, we want to make extra class for you in order to catch up with the other sections. Saturday, 10 o'clock. Okay, Saturday, 10 a.m. All right, Saturday, 10 a.m. Saturday, 10 a.m. Any objection? No objection. Okay, that's fine. So this coming Saturday, uh, you have any classes on Saturday? After tomorrow. After tomorrow. I will put in the group. I will put in the WhatsApp group, okay? Okay? So okay, if you don't have any classes, I believe that nobody has classes on Saturday, so that's why I make it. Okay. On Saturday, right. Okay, so on Saturday, 10 a.m., we have a replacement class for 2 hours, okay, from 10 to 12 or to 11:30, something like that, okay, and we might have some discussions as well, all right? Attendance for today, okay, today you will not take any attendance. It's enough for me that you are online, but next time, please prepare your cameras. Please prepare your cameras. Those who don't have have problems with their cameras, please prepare yourself to open the camera. Please prepare yourself to open the camera. From now on, I will depend on the camera as attendance. If somebody didn't open the camera without any excuse, without any certain situation. Okay, so that means he might be not attending. Okay, and when I record attendance, I must be honest. So if you are attending, this is the only way I can register your attendance and make sure that you are attending. Okay, so okay, that's all. So we meet next week. We meet on Saturday, 10 a.m. for the replacement. All right? Right? So thank you so much. Take care Have a nice day. Bye. I will see you. Jumpa lagi on Saturday. Assalamualaikum warahmatullahi wabarakatuh.